The 1975 GMC Motorhome. The changes that have been made on the 1975 models enhance appearance, improve reliability, performance, and operation of appliances. Several of these changes will also directly affect your pre-delivery preparation and repair service procedures. Should a 1975 model require paint or body repair, be sure to check the vehicle's serial number. Effective with vehicle serial number TZE 165V100189, motorhomes are painted with DuPont urethane trademarked Imron. Paint repairs on these vehicles should be made with Imron or equivalent class paint. Lacquers and acrylics must never be used to repair body finish of these vehicles. There are several automotive changes on the 1975 model. The accelerator pedal and mounting is changed to a suspended rather than floor-mounted unit. The accelerator linkage is now a cable that requires no adjustment and no lubrication. It is important that if cable replacement is required, the cable be routed exactly as the original. Like many other General Motors vehicles, this year's GMC motorhomes will be equipped with high-energy ignition systems on vehicles produced January 1, 1975 and thereafter. The high-energy ignition system does the same job as a conventional ignition system, provides spark to the spark plugs. But the high-energy ignition system is designed to deliver a much higher spark voltage with greater control, better reliability, and no scheduled maintenance. The most obvious difference of a high-energy system is a larger distributor unit that incorporates the high-voltage coil into the distributor cap. The lower housing contains a rotor shaft, timer core, pickup coil assembly, electronic module, and centrifugal and vacuum advance mechanisms. The timer core, pickup coil assembly, and electronic module replace the contact point set of a conventional ignition system. As the shaft rotates, a magnetic field between the timer core and pole piece is interrupted. The interrupted magnetic field induces a small voltage in the pickup coil, which signals the electronic module to open the primary circuit of the high-voltage coil. From this point, the HEI system functions just as a conventional system. The voltage, however, is much higher with HEI, approximately 35,000 volts at the spark plug. The electronic module is both an electronic switch and dwell controller, opening and closing the primary coil circuit for specified periods of time depending on the engine RPM. The faster the engine RPM, the more prolonged the dwell period. The module is a solid-state device completely encapsulated and designed for long-term reliability. If the module should ever fail, it is replaced, never repaired. Since there is no routine maintenance required for the HEI unit, the only service of HEI will involve a failure somewhere in the system. In the event of any malfunction that indicates ignition problems, first check the connectors on the side of the distributor and all spark plug leads to ensure they are properly attached. If an engine equipped with HEI will crank but not start, connect a voltmeter or test light from the battery terminal lead on the distributor to a ground point on the engine. Turn the ignition switch on. If the voltmeter reads 0 or the test light does not glow brightly, the fault is an open in the battery circuit and not the HEI unit. A reading of battery voltage on the voltmeter or a brightly glowing test light indicates power to the HEI unit. Determine if there is spark voltage reaching the spark plugs by attaching a good spark plug with 60 thousandths gap to number 1 spark plug lead. Carefully twist the rubber boot 1/2 turn to the left and right to loosen the lead wire from the engine plug. Pull only on the boot to remove the lead. At all times, handle the silicone wire with care. Install the test plug and ground the test plug body to the engine block. Turn the engine over. A visible blue spark means the HEI unit is operating and the problem is most likely elsewhere. But if a check of the fuel system reveals no indication of improper fuel delivery to the engine, rough check the timing by aligning number 1 lead post on the cap with the rotor and the timing mark on the vibration damper. No spark at the test plug requires a component check of the HEI unit. First, inspect the cap and rotor for burn spots indicating arc over. Then check the spark plug leads and boots for indication of damage, visual signs of arcing to ground or cross-firing. Before going further into component checks for a no-start condition, we should cover initial troubleshooting for a rough-running condition. We can then study the possible HEI component failures for both conditions. An engine that runs rough only at higher speeds and not at idle is most likely caused by a faulty electronic module. We will cover testing and replacement of the module in the components checks. An engine that runs rough at idle only is not an ignition problem, so first eliminate other possible causes by checking carburation and vacuum lines. Because HEI delivers a much higher voltage, arc over to ground may be more likely than with conventional ignition. Visually inspect and listen for arc over. Next, check ignition timing. If initial timing is correct, remove the distributor cap by turning 4 latch pins and check the operation of the centrifugal advance. Also, inspect the cap and rotor for arc over, cracks, or excessive wear. Replace these components if any fault is indicated. After assuring proper timing, and if there is no indication of arc over, remove all the spark plugs and inspect them for possible fouling, cracks, or improper gap setting. No spark at all, or an engine that continues to run rough, requires a components check of the HEI unit. First, check the coil primary. Zero an ohmmeter set to the lowest scale and connect the leads to the tachometer and battery terminal of the cap as shown. The ohmmeter reading should be 5 ohms or less. If the reading is higher, replace the coil. Next, set the ohmmeter to R times 1000 scale and zero the meter. Connect the leads to the battery terminal and the center rotor contact as shown here. The reading should indicate high resistance, approximately 20,000 ohms, but should not be infinite. A reading of infinite requires replacement of the coil. If ohmmeter readings are normal, remove the coil from the cap and inspect for arc over at the spring and seal. Evidence of arc over indicates deterioration of the seal, which should be replaced. If arc over has caused damage to cap or coil, they must also be replaced. If the problem of a rough-running engine has not been located by now, only 3 possibilities remain: faulty vacuum advance, pickup coil, or electronic module. A defective vacuum advance will not keep an engine from starting and can be eliminated as a problem if the trouble is failure to start. To check the vacuum advance, connect a hose from the advance unit to a vacuum source. Visually inspect the bellows action as vacuum is applied. If the vacuum advance does not operate, replace the vacuum bellows unit. To determine possible failure of the pickup coil, set an ohmmeter at mid-range and zero the meter. Connect the meter to the HEI housing and lead from the pickup coil as shown. Operate the vacuum advance while observing the meter. Replace the pickup coil if the meter reads anything less than infinite at any time during the stroke of the advance unit. Reconnect the ohmmeter to the pickup coil leads as shown. Using the same range, again operate the vacuum advance and observe the meter. The reading should not be less than 500 nor more than 1500 ohms. The pickup coil should be replaced for any reading above 1500 or below 500 ohms. All components have now been eliminated except the electronic module. If no fault has yet been found, the module is very likely defective. Before installing a new module, be sure to apply a layer of silicone lubricant between the module and HEI housing. This lubricant, which is supplied with the new module, insulates the module from engine heat transfer. Special test instrument J24642 is available to diagnose the electronic module. Instructions for using this equipment is provided by the manufacturer. Now let's look at changes in other systems of the 1975 GMC motorhomes. We'll start with the battery system. A dual battery system now serves all 12-volt requirements of the motorhome. The motor generator battery has been eliminated, and the living area battery has been moved from the engine compartment to the area that formerly housed the motor generator battery. The living area battery now also serves as the motor generator battery. This change required the use of a heavy-duty battery with a capacity rating more than double that of the earlier living area battery. The new battery has a rating of 150 ampere hours. To eliminate long-period drain on both batteries, the battery boost switch has been changed from a locking throw to a spring-loaded momentary design. When extra power is needed for the automotive circuit, the boost switch must be held in the battery boost position. The switch automatically returns to normal position when released. The battery boost switch provides extra electrical power for the automotive circuit only. If the living area battery is low, start the vehicle engine. The living area battery will then be charged by the automotive Delcatron generator. The AC-DC power converter is now a 45-amp capacity unit with a prolonged voltage curve. Circuit breakers and the 12-volt fuse panel are both located in the same compartment with the converter. All 12-volt fuses are now one current rating, 15 amperes. A built-in service convenience is the new hour meter for the motor generator, located beside the motor generator start-stop switch. The hour meter helps ensure regularly scheduled maintenance of the generator. A 6,000-watt capacity motor generator is standard equipment for the 1975 motorhome. Plumbing and fixtures for the fresh water system incorporate new materials and design. The galley sink fixture is now a single control unit to mix hot and cold water. Service of the new fixture is fairly simple. The first thing that you should do is remove the chrome cap and lift off the control arm. Then, unscrew the retaining nut and lift off the spacer cap. Remove the clip that holds the control element in the fixture body and lift out the element. The control element is a stainless steel rod in a brass tube. Separate the tube and rod by removing the snap ring and pulling the rod out of the tube. Remove the rubber seals from the tube and rod. Do not use any tool that could score the seal seats, because scored seats could result in leakage. Install new seals. After removing the seals, coat both rod and tube with silicone lubricant and reassemble the fixture. You can procure the silicone lubricant locally. Nearly all of the plumbing on 1975 GMC motorhomes is polybutylene, a plastic capable of containing frozen water without rupture. And if a section of the plumbing should be damaged, it can be easily repaired. If the damage involves only a small area, it may be repaired with a coupling section. Measure the length to be removed, allowing 1/8 inch for flaring each end of the pipe, and cut out the damaged section. Install flare nuts over each section of the pipe to be joined before you flare the pipe. After installing the nuts, flare the ends of each section with the special flaring tool J26227 as shown. The flare must be clean and symmetrical for a tight fit. Do not exert excessive pressure on the pipe while flaring. A moderate pressure will result in a clean flare without splitting. Install flare inserts in either end of the coupling and place the coupling between the pipe sections. Hand tighten the flare nuts to the coupling. Do not attempt to tighten the plastic fittings as you would copper or brass fittings. apply only a light torque with a wrench to snug the fittings, no more than 15 inch-pounds. The extensive use of polybutylene plumbing and the pulsation damper incorporated in the freshwater pump offers protection of the system against accidental freezing. However, for storage at temperatures below freezing, the entire water system must be drained and prepared as outlined in the owner's manual. In the event frozen water blocks the plastic plumbing, thaw with hot air blower or electric heater. Never put direct flame onto the plastic plumbing. A freshwater filter installed between the water tank and the water pump will require periodic inspection. The filter is transparent and should be replaced whenever the screen becomes clogged. Access for inspection and servicing of the water tank, filter, and pump has changed slightly in 1975 from previous models. First, remove the kick panel in front of the right rear settee by carefully pulling toward you. Velcro strips hold the panel in place. Remove the access panel. Inspection and minor service of the tank, filter, and pump may be made through the opening. For major repairs or service, the right rear settee must be removed. To remove the settee, take out the 2 Phillips head settee attaching screws. Then lift up and pull out on the seat. A number of flathead wood screws attach the top cover. Removing the top cover screws and lifting the cover exposes the water pump and tank for service. The 40-gallon water tank may now be filled directly by coupling a hose to the filler neck. Remove the top fill cap when using the hose connection to fill the tank from a pressurized water source. This allows air to escape from the tank. The new filler neck design helps keep contaminants from entering the tank. Be sure to replace the plastic caps after filling. For connecting to city or park water supplies, a separate water connection with built-in pressure valve is located in the external utilities compartment. The pressure valve protects the freshwater system from excessive pressure. Ensure proper function of the valve during pre-delivery preparation and regular maintenance intervals. An option in previous models, the hot water heater preheater, is now standard equipment on GMC motorhomes. The preheater operates by circulating engine coolant through hoses to the water heater and back to the engine. The Magic Chef 3-burner stove and oven replaces the Coleman unit in all 1975 GMC motorhomes. There is not a great deal of difference between the Coleman and Magic Chef units, but there are some service features that should be recognized. Just as a precaution, for yourself and your customer, check the burner control knobs at the front of the stove to assure they are attached to the proper burner before attempting to light the stove. There are 3 separate gas shutoffs on the stove, a mainline shutoff on the manifold inlet, and 2 pilot valves, one for the top burners and one for the oven. To remove the stove, shut off the gas at the LP tank, disconnect the gas line at the manifold valve, and remove 6 screws, 4 at the top and 2 beneath the chrome trim in front. The furnace in 1975 GMC motorhomes is also new, a 30,000 BTU forced air unit manufactured by Soul Air. One of the features of the furnace is an automatic spark igniter that eliminates manual lighting of the furnace pilot. To increase the heating efficiency of the new furnace, a ducted cold air return has been added to the heating system. Cold air inlets in the front and rear of the vehicle recirculate air through the furnace, reducing the amount of energy required to heat the living area. Circulation has also been improved in the bath module by ducting warm air to either an aircraft-type air outlet or constant flow vent installed on the bath module wall. Access to the reset button and fuse is through the compartment door from the front. To adjust the burner or perform other service on the furnace, the Davo must be raised. To raise the Davo seat, simply squeeze the levers under the center of the seat and lift. If major service of the furnace is required, the davo and frame must be removed. After lifting the cushion, remove the front trim panel. Disconnect the air ducts, remove the 8 half-inch hex head lag bolts around the perimeter of the frame, and lift out the whole unit. Access to ceiling ducting and wiring has been made easier in 1975 GMC Motorhomes with 5 ceiling panels that can be removed independently. Each panel is held by steel retainers attached with screws to the roof support cross members. To remove a ceiling panel, take off all fixtures attached through the panel. Snap off the trim cover and the vinyl side molding, unscrew the retainers, and the panel will drop by its own weight. To remove the number 1 panel in the front of the motorhome, take off the vent faceplate and remove the overhead cabinet before removing the retainers. Both front and rear ceiling panels are also supported along the outside edges by roof rail extrusions. When the retainer strip has been removed, the panel will sag, and the panel edges can be pulled from the extrusion channels. Number 5 panel in the rear is also held by the 2 overhead cabinets. These can be removed by unscrewing 4 hex head bolts in each cabinet. After the cabinets are off the ceiling, the rear panel can be removed in the same manner as the front. Similarly, ceiling panels 2, 3, and 4 that span the galley and the hallway have overhead cabinets, ceiling lights, electrical outlets, and the air conditioning plenum chamber. The cabinets must be taken down by removing 6 hex bolts and the faceplate of the electrical outlet before the panel can be lowered. This has been an overview of the 1975 GMC Motorhome. More detailed service information is available in your service manual and bulletins. Information concerning modifications to the air suspension system is in film MH-14, and instructions for servicing the Soul Air furnace is in film MH-15.